Hi. Okay, this time let's rationalize the denominator using conjugates. Okay, let's know first what are conjugates. The first time you encounter conjugates is in the idea of difference of two squares. I hope you remember difference of two squares. When you have difference of two squares, that means you have x minus y times x plus y. This will give you x squared plus minus y squared. Okay, so these two are what we call the conjugate. So when you're looking for the conjugate of x minus y, that will be x plus y. Why do you think this is helpful for us to know? Now let's take for example, of course, when you're dealing with algebra, example x minus 3 or 2x minus 3 times its conjugate 2x plus 3, that will give us the quantity of 2x squared minus the quantity of 3 squared. So this will give us 4x squared minus 9. Okay, so you don't have to use FOIL method in order to simplify or to combine these factors. Okay, now how about when you're dealing with radical expressions? So let's take for example 3 minus square root of 2. Multiply it by its conjugate 3 plus square root of 2. And when you do this, you can also apply the OTS, whether it's radical expression. So when you do that, you can actually have the square of the first term, which is 3 squared, minus the square of the second term, which is square root of 2 squared. Okay? Observe that we have 3 squared, that will give us 9, minus 2 squared can be cancelled. Square and the radical can be cancelled. It will give us 2. So 9 minus 2 is equal to 7. Okay? The amazing thing about multiplying conjugate in radical expression is that you can actually arrive with an integer. Okay? It could be negative or positive. So for example, I have square root of 7 minus 3. What is the conjugate for this one? The conjugate is square root of 7 plus 3. So when you're dealing with conjugate, the first and the last terms are of equal value, but the operation that we use for these factors are different. So when you do that, you can actually apply the idea of difference of two squares, giving you the square root of 7 quantity squared minus the square of 3. So when you do that, you can cancel out 2, that will give you 7, and 3 squared is equal to 9. So that will give you negative 2. So observe that I have gotten a negative answer here. So just remember that negative 2 is still a rational number. Okay? So the beauty of multiplying conjugates in radical expression is that you will always arrive at an integer. Okay, now let's apply this idea. So what do I mean by that? Let's say for example 1 over square root of 5 plus 3. Okay, so how do I rationalize the denominator? In order to rationalize the denominator, our target is to remove the radical symbol in the denominator. Okay, when you multiply this one by the usual way that we do, like example multiplying by square root of 5 plus 3, just like what we did in the first part of rationalization of denominators, we can actually get square root of 5 plus 3 all over. You can use FOIL method here. That will be square root of 25 plus 3 square root of 5 plus 3 square root of 5 and outer to outer, or last to last, equal to 9. So when you simplify this further, that will be square root of 5 plus 3 all over square root of 25 is 5. 3 square root of 5 plus 3 square root of 5 is 6 square root of 5. And this is equal to 9. So simplifying it further, that square root of 5 plus 3 all over 5 plus 9 is equal to 14 plus 6 square root of 5. In this case, our final answer still has a radical symbol, so which means we haven't rationalized the denominator. So how do we rationalize a denominator if you're given with addends and one of the addends is a surd or a radical expression? Okay, this is where your idea of conjugates will be applied. Okay, so remember that when we're multiplying the expression by its conjugate, you will always arrive at a certain integer, whether it's positive or negative value. That means maybe we can apply the idea of conjugates here. Let's try what is the conjugate of square root of 5 plus 3. The conjugate of square root of 5 plus 3 will be square root of 5 minus 3. And remember that you have to multiply this whole thing by 1 to make the value equal. So it will not change the value of the original expression. So I also have to do the same thing in the numerator. Okay, when you do that, that will give me 1 times square root of 5 is still square root of 5. 1 times negative 3 is negative 3 all over. When you're multiplying two conjugates here, you are applying actually difference of two squares. When you say difference of two squares, you're squaring the first term minus the square of the second term. Okay? So that's the idea. So just remember, x plus y times x minus y is equal to x squared minus y squared. So when you do that, you can have square root of 5. This is not equal to this. So minus 3 all over. You can cancel out squared and the radical symbol. That will give you 5 minus the square of 3 is equal to 9. So simplify this further. That will be negative 5 minus 3 all over negative 4. And that will be your final answer. But of course, you can rewrite this as, negative of square root of 5 minus 3 all over 4. Okay, so this is your final answer. Okay, let's try this example. So in this case, we're dealing with 2 thirds in the denominator. But don't worry, we already know what to do. Okay, so when you're dealing with 2 addends in the denominator, then you just have to multiply the denominator by its conjugate. So remember how to make a conjugate. So in this case, we have square root of 3 minus square root of 2. So you also have to do the same thing in the numerator to maintain your value of the given equation or expression. So that will give us 4 times square root of 3 is 4 square root of 3. 4 times negative square root of 2 is negative 4 square root of 2. All over. Now, whenever you're multiplying conjugate, remember you're squaring both terms. The first term, square root of 3 quantity squared, subtracted by the square of the second term. When you do that, you will have 4 square root of 3 minus 4 square root of 2. And what happens when we do this step? We can actually cancel this out, and that will give you 3 minus 2, and 3 minus 2 is equal to 1. So definitely your answer is just 4 square root of 3 minus 4 square root of 2, because if this is all over 1, then your final answer is just 4 square root of 3 minus 4 square root of 2. Or you can have 4 times square root of 3 minus square root of 2. Okay, so that's how you use conjugate in order to solve this kind of problem. Now, I want you to investigate what's actually the difference between, if you're given the values, let's say 3 all over square root of the sum of x plus y, and 3 all over square root of x plus square root of y. Try to investigate if they're equal or not. Okay, that will be a challenge for you. Bye.